Sounds good.
All right. Johan, why don't we wait like an extra minute so that a few of
Yeah,
the people that are kind of stranglers can join.
sounds good. Alrighty. So we have 14. While we're waiting, if you guys don't mind, just drop in the chat. It's always interesting to see where people are from. I'll start. I'm in South Florida. I'm like 40 minutes, 45 minutes from Alex.
Yeah, I'm in South Florida. I'm kind of right in between Palm Beach and Fort Lauderdale. So, and if you guys don't know where that is, it's about an hour north of Miami.
For you, that's an hour. For me, if with traffic, it's like 3 hours. That's the problem with everything is 3 hours from here.
Yeah,
Orlando, my,
yeah, you're
uh,
you're 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 way up there.
so let's see. We have a couple of people still joining.
Okay,
All right.
awesome.
And let me see. We have Q&A. Earth 59 in the multiverse. Yes, Michael. if if only we could all just live in the multiverse, right? Have portals. I can't wait for that. All
That'd
right.
be awesome.
While we're waiting, just the theme for today is going to be, we're going to talk about AI in context of, how to get it into production, some of the struggles that people are going through. We have four main topics that we want to cover, and we'll get into that. But just for the folks that's already joined to get you started, if you have questions, please drop it in the QA. We have some folks that's going to monitor that for us, and we'll leave the last few minutes for everybody to, kind of get their questions answered. Um, but the four areas that we're going to cover is why AI projects slow down after. We've heard a lot of this. We're going to talk about that. Companies asking us, can we just go into production, skip the pilot, things like that. We're also going to talk about scaling AI across teams, across systems, processes. What goes into that. Um, a lot of what we hear is people's, are like, we don't want to hire more people. We want to use AI to be more productive. Well, that works only if you have the right systems and processes. So we'll talk about that. We also are going to talk about building teams ready for AI-driven development and what that means. We have a pretty unique perspective on how we approach it, I think, and we're going to talk about that. And then we want to end with just some lessons that we learned from some of the real world applications that we have been working on. I want to say for the past 2 years, majority of it, but there's definitely, some of these projects where the same lessons get learned over and over. And we want to cover that. So we stop learning and we start implementing. So those are the four main areas we're going to cover today. If you're wondering what this topic is about, that is it. I think we're ready to start. We have a lot of participants already. If you're ready to drop your questions at any time, drop it and we'll get to that. But in the meantime, we'll do introductions. Alex, if you don't mind starting, and then I'll go.
Sure. Sure. My name is Alex Barenboim. I'm the Chief Technology Officer at Svitla Systems. I've been here for almost 2 years now, and I've had a long career path of starting as a software engineer and over many years, going up the ladder to becoming a CTO, which I've been doing for the past 10 years or so. My expertise is in software engineering, uh, the entire breadth of that field, including AI. And I actually worked with Johann years ago at a company called Bankrate, and that's off to you, Johann.
Hi. So I have to apologize if my sound goes out. We are having like thunderstorms, this typical Florida weather. So just let me know, Alex, if it goes in and out.
No
But
problem.
quick introduction. I'll start where Alex kind of hinted. We used to work together about 15 years ago or so, and at the time Alex was my boss, and I learned a lot. I went back to school after that, and I focused on data science. At the time, Hadoop and Cloudera and all those technologies were becoming MapReduce was the big thing, and I wanted to learn more about how to analyze and data mine the data. Got into robotics, got into one of the first deployments of Boston Dynamics robots. So that has been kind of the trajectory after software development for me. A lot of lessons learned, a lot of pain. And that is one of the reasons when I joined Svetla, I got this title that's like an interim title. Everybody always asks me, what does Chief AI Officer mean? And I'm like, it's just what we call people that know AI for the next couple of years until it becomes the CTO again. So if you're a CTO today, in the next 2 or 3 years, you'll be able to add, you're also a Chief AI Officer. I'm pretty sure of
All
that.
right.
All right. So that based on that, I want to start, Alex, just kind of like touching on, and I'll get us started. But we hear from a lot of clients. I want to say the theme for 2026 is, we've done the pilots, we've done the POCs. It's easy to vibe code and over the weekend get something in production. Can we just skip and go directly into the MVP or the beta phase? Or, oh my goodness, I've heard this too. Just put it in production.
Yeah.
And there's reasons, and obstacles around that. And I'll get us started. One of the biggest problems with that is, and we run into this, is you have a smart engineer, they vibe code some solution over the weekend, they use Opus, the latest, the greatest, or maybe now Fable, the latest, greatest model, and it works really well, no doubt, right? But now you have to scale it. You have to get into production. And
Right.
the cost of the tokens, the security, there's so many things that goes into that needs to be considered. And from a technical point of view, just your experience on more on the engineering side, scaling this with Docker containers and Terraform and all that becomes the bottleneck, right? So
Yes.
how do we get from that mentality of everything is a pilot and it can go to production? How do we get, what's the process that you know of that works really well getting that into production that you need to look out for?
So from a scalability perspective, and actually I wrote a book a few years ago, and I had a chapter about scalability. Scalability is something that most people never have to deal with. They develop a database, they develop a web platform that maybe has hundreds or even thousands of people hitting it on a daily basis. That's not really scalability. A good computer with an i9 with 32 gigs of RAM and an SSD for a database, it'll be able to pump out, it'll be able to handle at least a few thousand people coming to it on a daily basis. Even if you're doing financial transactions, even if you're doing, complex other complex things, it's not that difficult. The challenge what happens is when you're one of those very small number of companies that truly have a scalability issue. So, for example, someone like a Facebook, where you literally have hundreds of millions of people hitting their servers all the time. I have some friends who work at Facebook, and they tell me that, they have close to 500,000 servers to be able to handle that stuff. They decided in their wisdom to take the server concept and make it super cheap. I think every one of their servers is like $1,000, $1,500, something like that. But they have literally hundreds of thousands of them. Instead of, the old days where you have a big IBM mainframe, where you have massive amount of capability, massive amount of I/O to be able to handle it from one environment. Um, Citibank, as an example, they have a gigantic IBM mainframe that handles about 5,000 transactions per second. So something like that is very, very difficult to put off. But from a scalability perspective, you have to start thinking about how do you get the data out of the databases that you have? How do you partition the data? How do you shard the data? How do you normalize the data? And that's just the data side of it. I'm not talking about the routing of information, the processing of the information. It becomes literally a nightmare. So back in, if you recall, back in the bank rate days, we had a widget that we put available on the Yahoo Finance page, and it was being hit 700 times a second. And I remember you and I were in the same room banging our heads against the wall, like, how are we going to do this? Because even having a $20,000 server back in the day was just not going to be able to do it. So we had to come up with caching algorithms and folding techniques and all kinds of other things in order to scale that kind of a solution. And that was just a very small group of people trying to figure out just this one little widget. You take it 1,000 steps further, and you have a company like Facebook that has literally hundreds of thousands of servers dealing with regions and all kinds of other things. So scalability is something that's very, very complex. And if you ask an AI model, hey, I want to build a website that will be able to handle 1 million hits a day, I'd be interested to know and see what it will result with. So it could be interesting to see that. But that's some of the challenges of software engineering is this particular field.
So the moving back to that whole pilot, I vibe coded something, I got it done over the weekend, I proved it worked, but now I have to get it to production, right? If you think about what's the focus, what's the purpose of pilots, it's to optimize and prove feasibility, right? That's it.
Right.
It's not judged by reliability, it's not judged by cost or support or anything. It's two different bars. So what we typically do on my team when we work on AI projects is we start small. And I saw there's a question from Russell asking about, what is scale in terms of transactions per second, 10,000, 100, and plus. The reason we start small is we typically do an 8 to 10 week, let's call it a sprint, right? During that time, we're building the base model or the base agent or whatever the AI technology is going to be the core of, right? The reason we started that is we need to build it in isolation from website integration, mobile applications, all kinds of stuff. Because if your AI is not solving the business problem, why would you scale it? I mean, why would you go build the server racks and everything else if you don't even prove that AI can solve the problem? So we always start with problem first. What is it that we're trying to solve? And then can we solve, and is it the right tool to use for AI to solve that problem? If you think about the data set, Alex, you talked about that. Very often pilots will run on a curated data set, right? It is something that you exported. It is perhaps even already cleaned. It might be a complete data set because you're using a subset. So I don't trust the data in a pilot. It's just not one of those things that I can do. So we have a process how we have testing data, validation data, and how we actually train the models and evaluate them to see if they will generalize when we put them in production. But the basic premise is that pilots are really not meant for production, right? That's not the scope. You want to test out feasibility, data availability, data quality, all of those things first before you go to production. However, you don't want to do it in isolation, forgetting about the production, because that is going to come up. All right. So when we think about that, right, that integration tax is really something that we deal with in software development all the time. And what I mean with integration tax, you think about authorization, data pipelines, audit logs, PII handling. There's latency. I remember the use case you're talking about with that widget that we had. Mm-hmm. We at the time were moving from, I want to say, classic ASP to ASP.NET, and
That's
ASP.NET right. would compile like binaries inside each folder, and it was just it was chaos. It was very difficult to scale. We had some smart engineers too, so credit to them, figured it out. But it was something we haven't done before. However, over the weekend, those smart engineers were able to build a framework, and they did it without vibe coding. I mean, we didn't have AI tools back in those days, right? So the intelligence were there. People were smart enough, but the problem is that the conditions that you have in production doesn't exist in the pilot area, not in the form of data, not in the form of infrastructure and tax and all that stuff. So I think that is one of the biggest lessons that we've learned over the years. When we approach AI projects, we always do it with that mindset of, we're going to test the pilot, we're going to test the feasibility, but we have to do it in such a way that it can scale. And that's where we have that 8 to 10 week, that first phase, that first sprint, where we just focus on how do we build the AI tools to be scalable and meet the business need. So I'm looking at some of the questions. Do you see a healthy conflict between CTOs and CEOs and CMOs, where one side says it should be easy and the CTO is unable to convince? Okay, so very good question, and very applicable to this conversation. So I'll get started, and then I want to hear what you say, Alex. I think one of the biggest challenges is being able to prove return on investment, ROI. We at Svetla, I'll tell you guys, we don't do experiments. If a client comes to us, let's say Rakesh, you came to us and you said, "Hey guys, I have this idea and I want to see and check out and see if it's feasible and this and that." That's great, but we're going to pinpoint, we're going to work with you to get to a point where you tell us what is the measure of success. If you cannot demonstrate and tell us what that is, and we can figure it out together, why do it? This is not in high school or in college where you write a paper at the end of doing some work and that's your deliverable. We're in business. We have to deliver business value. So we have to always couple a business ROI to whatever that project is. I'll give a quick example and then I'll throw it to you, Alex. So if one of the projects that we're working on currently is a financial agent, right? And right now we have fractional CFOs in the financial area that uses the tools and those agents to just save the amount of time they spend on reconciliations and audit reports and stuff like that. They're still doing the work, but instead of them reading through all the documentation and summarizing it to evaluate it, the AI does that for them and it gives them hints. So you still have a human in the loop. So the ROI calculation there is numbers of hours that it took the CFO before versus number of hours using an AI tool. Very easy ROI calculation there. But it's not always that straightforward, right? Sometimes it is we're increasing safety or we're decreasing risk. And that is where the challenge comes in. And another way that we do it is we have workshops, and we go through these workshops using design thinking. It's one of those methods to kind of get to the core of the problem that you need to solve. And we evaluate every single project that's on the board according to what those ROI measures are going to be. Alex, if you think about like some of the projects you've worked on, right? How often have you had to go convince somebody to get the budget for the next phase, showing value of this phase in order to get that budget? Because that's really the core of it, right?
Absolutely. And this is something that I do. This is something that you do. This is something that most of our senior consultants do, probably on a daily basis. There have been, dozens and dozens of clients that I've engaged with over the last few months where we build them some kind of a solution and they're very happy with what we built. And they're like, okay, well, what happens then? Well, okay, well, where do you want to go? Are you generating the revenue that you were expecting? In some cases they do, in some cases they don't. Are they trying to build a bigger team in anticipation of having more customers come through the door or be able to generate more revenue or things like that? So from a software engineering perspective, we have to be ready. We have to have the resources. We have to have the understanding of what's version 2. We have to understand exactly what will be in it and how it's going to work and how it's going to be augmenting from what version 1 is. But the real question is, has the customer really thought about this? And this kind of goes back to the .com days where people just assumed that you have a .com in your name, you're going to be rich and make tons of money. And today I think it's very similar. Just because you put AI into it doesn't mean it's going to be wildly successful. You have to think about, what else comes with this AI. AI is a wonderful tool. I use it every day. I know, Johann, you use it every day. We do amazing things with it, and it is amazing how much it can do. But the real thing is, from a software engineering perspective, and I remember I went to school, as did you, and I have a degree in computer science and whatnot. And, software engineering, the actual coding, was part of the overall solution. But there are other things that you need to think about. You need to think about the architecture. You need to think about the data. You need to think about the revenue. You have to think about customers and how you're going to return products that are going to be broken along the way and all these other things that have nothing to do with coding. It's a business, right? So back to the ROI, super, super important, and probably even more so now because of the speed in which, like you said earlier, a developer on Friday night thinks of some interesting, brilliant idea, when he's, walking his dog outside, he goes back into his computer and he doesn't leave, the office until Monday morning, doesn't go to sleep. He's just coding all day long and all night long. And he comes up with something. Okay, but is it going to generate money? Is it going to improve someone's life? Is it going to create a business? These are the kinds of things that software engineering is moving to. We're no longer just going to be writing code, but we have to start thinking about why are we writing this code? Who is it going to help? Who is it going to hurt? How are we going to, corral all these things? These are the kinds of things that AI can't help you with yet. Maybe in a few years it will be. And then we have to think about what else we're going to be doing instead of
Yeah.
that.
Well, that's a good segue into kind of the next topic, which is, scaling your AI across teams, systems, processes, because I think, we kind of all agree when you're building a platform of, AI capable solutions, right? Let's call it that, because almost every piece of software today includes some form of AI. It's amazing. I mean, you look at all of the the vendors like SAP and Oracle, Snowflake, they're all injecting. I mean, Office and Google, Workspace, they all have AI agents to help you, co-pilots and stuff like that. So it's becoming part of every piece of software, right? But the problem is that you don't want to build a portfolio of pilots. If you're a CTO and all you have to show at the end of the quarter is a bunch of pilots, it's not a good thing. So you want to kind of reinvest the time and effort that your team used to take coding every single line of code and kind of elevate up to what you just described, understanding the business. And I think this is the number one. If I get asked this a lot, what do I think about computer science degrees? What do I think is the future of developers, stuff like that? I'm very honest and I say, you know what? When I started coding, we didn't have IntelliSense. We were a little bit better than what was it? Notepad. It was a
Yeah.
little bit better than Notepad. Not much better, right? But IntelliSense came along, and then we had UML diagrams that was integrated in live environments, all kinds of stuff. My point is that role of coding is evolving, and the new set of skills that you need as a developer and also as a CTO, a VP, a director, everybody, you need to be able to understand technology in the context of business. That needs to be merged. And I think it makes the case, a couple of years ago, it might have been less so, but it's making a comeback for people that's got a degree, like an MBA degree, some kind of business savvy degree, an economics degree. Those are things that I would invest time and effort in. Doesn't mean you're not going to do computer science. That's super important because somebody needs to evaluate the code. And if it breaks at 2 a.m. in the morning, who's fixing it? It's probably a human. So there's still a place for computer science and coding, but being able to understand the business, explain it, come up with the right requirements, all of those things are important. Now, I want to touch on one more thing. Just one of the questions that we had was about agentic development, because it kind of touches on this topic around scaling and your team. When we built agents, and Dimitar, you're asking about that, right? We have a very tight process, and this is what I was talking about earlier. We learn by pain. Everybody, I think, learns by pain, but every time we find the pain, we then try and find a solution, either technology, workflow, combination of the two. When we build agents, one of the things that we do is we start with a archetype. We then identify the different roles or the different personas for that archetype. Then we map the journeys and we go through and we say, for each one of those personas, what is the task that we actually need to map out? If I was to write the SOP for a new employee, what would that look like? Then we take that journey, we break it up further, we look at decision points. At what point can we have AI make a decision versus AI suggesting and a human make the final decision? That's the human in the loop, right? Then we have inventory of all the tools that journey needs. Access to a SharePoint site, access to a database, have a tool called to generate an image, whatever the case might be, right? So we have, to answer your question, a very defined process of how we build agents. Just like you did when you did software development, and you would start with a diagram for a database schema or a diagram for an object-oriented application, whatever the case might be. People kind of forget that you need to do upfront design, even for agents, even for AI. The AI by itself is not going to figure out who's the manager agent and who's this and who's that. So we always have that process in place. And then I can tell you two different, you asked the question about a management agent. When I'm coding, and we also teach coding, and we'll talk about that in the next topic. When we use AI tools for coding, I personally have a dev manager agent that oversees. And the instructions for that dev manager agent is to never code, never do QA, never write the document. It's a typical manager. I'm kidding. I'm kidding all the managers. No. It just supervises. It coordinates, it supervises, it keeps track of the different work trees. When the code gets merged, it makes sure that the test plans and everything is aligned with that. So its job is to truly oversee so that I, as a human, can trust that agent to check off all the minutia and I just look at the results. Okay. If we create the same concept for other agents, we do the same thing where we have a manager agent. When I talk about archetypes and I talk about personas and journeys, we'll look at what is a management agent that we can include that orchestrates all of that. And we build that management agent as one of the agents that part of the team. I'll give you one example that I love the library. I don't think it's the best one. So don't quote me as this is Johann saying it's the best, but there's a framework called Crew AI, CREW AI, Crew AI. And the concept is the same. You have a crew of agents and they focus on a specific domain like marketing or finance, whatever. And then inside of those, inside of the crew, every agent has access to tools and tasks. But we always have a management agent that's basically the manager of that crew. And that manager is responsible for external communication with other crews and internal communication and coordination with the team. So with all that explanation, my point is really you need to have frameworks, you need to have systems. And this is kind of, getting back to the topic, you're scaling your AI across your teams, systems, processes. I think change management is a huge part and people forget about it. When you're introducing tools, it's a little different from introducing intelligence. We're not introducing just another tool. Like when Alex and I remember Alex, when we migrated to Visual Studio Enterprise, that's one of we went, I think, oh my goodness, I can't remember what the editor was we used before, but now it came with Team Foundation Server, which managed our code and all those things. That was a big change for the team, right? We had to get training. We had to, pay new licensing, a lot of things that went into it.
And it wasn't cheap either.
Not cheap, no. But now imagine we did that and we added intelligence instead of adding more people to the team, right? You really need to have change management mindset because you're not just adding a tool, you're adding visual source safe. Yes. No, I do not miss it, Michael. So you do need change management to go along with introducing AI. And it's another piece that I think people forget. The last thing I'll say, and I want to hear what you have to say, Alex, is when we do unit testing and we do integration testing with software, that's standard these days. Most teams, if they're really good at engineering, they'll have that in place. CI/CD, integration pipelines, things like that. What I see is missing a lot of times are evals. And I want to focus, I want to say evals are the new test suite. If a team cannot tell you their pass rate and what is regressed, they can't safely ship. That is a blatant statement that I'm making. I know it might be very controversial, but if it's controversial, you're not testing appropriately. So evals is really a new test suite that needs to be added. So that's one example of a workflow, a system. I want to hear, Alex, what do you think as far as your engineering team, some of the practices?
I think that, yeah, I mean, I think in the last few months, I've spent more on QA than anything else. It seems that you tell the AI model, do this, and it says, okay, and it does it. But it's not exactly what you wanted because you just gave it maybe a few paragraphs, maybe even gave it a whole page, but it's not exactly what you want. And it doesn't do everything that you need. So you have to test the crap out of it because it's going to all of a sudden do something else. It's going to start hallucinating. If the context window starts to blow up, I spend way more time on QA than I probably ever have in my entire career. And
Yeah.
it's fun because I get to see exactly how it's thinking. I get to see
Yeah.
what its limitations are. But yeah, QA is the most important thing right now with
You,
AI because you need to make sure that it's doing what you want it to be doing.
you know what's funny? Do you think just 2 years ago, you and I or anybody would have said QA is fun?
Yeah, right. I mean, like for example, the other day I told it, okay, um, it's time to figure out how you're going to do your taxes. So, okay, well, I figured, I went to an accountant every single year for the past I don't know how many decades, and I'm thinking to myself, okay, there is a process, there's some kind of mathematical formulas that they use, there's a huge amount of tax uh, uh, rules, these tax codes. I bet you an LLM can do something like this. So what I did was I took my real tax returns, my 1099s, my W-2s, all that stuff, a bunch of receipts, and I diligently went in and I removed my name and social and the real amounts and everything else. So it looked real, but obviously the data was not real. And I stuck it in there and I said, okay, build me a return, and it built me a return. Now I looked at the return and I compared it to how my accountant did the return. I gotta say
Yeah.
there was probably around a 20% variance. So the
Okay.
accountant was 20% better. But
Okay.
that was like I would say that was like 2, 3 months ago.
Yeah.
Now
Well,
imagine what will happen 2, 3 years
correct.
from now.
Well, so this is kind of touching on one of the questions that we have, right, around just guardrails, and I want to talk about
Yep.
that, and it also touches on the, Manas is asking about have you used the right context. So let me touch on both those topics because they're kind of related. So you can get away today with not using the smartest models, and you actually shouldn't use the smart models for most of what you're doing, and here's why. Opus, Fable, GPT, what's it, 5, 6, all of those models, they're doing a lot of heavy lifting for you because people aren't great at writing proper context. And I'm not saying prompts, I'm saying context because the missing part from the prompt is people don't give it enough context. For instance, when we teach our training for our engineers using AI tools, there's two skills that's critical, absolutely critical. You can't get away. This is, if you're Svetla certified AI tool developer, you know this by heart. We have a start session and we have an end session skill, two skills. Start session goes to Jira, it goes to Confluence, and it goes to GitHub. It uses MCP and it brings all that context local so that your project and your tools locally have an understanding of what is the priorities that I have to work on, what is the latest and greatest requirements documented in Confluence related to this project, and what happened in GitHub. Alex was checking in something at midnight last night. I want to know about it. Now, you can do all of that yourself. If you go every morning and you're disciplined, you can go read through Jira, see what changed. If there's any details that's missing, you can go to Confluence. But how long is that going to take you? And also, we're human. We forget stuff. We're not really good at, context, keeping a lot of context in our brains. So we use the start session to get all of that context. Now, if there's a new requirement, let's say Alex sent me a new requirement on Slack, and it's a document, we have another skill that loads that context into the bigger context on my local machine. The reason we do that is AI needs context. People forget about that. And it's the number one problem that I see when AI fails. You can always trace it back to it didn't understand the question, or it made assumptions, it hallucinated because it was trying to please you without really knowing what it's talking about, right? So the point there is whenever we have processes in place, being it for developers, being it just using AI tools, or if we build agents, autonomous agents, we always make sure that we load the context needed for that specific task. Now, why is that important? Well, all that context that I just told you about, if I were to keep that into every session when I'm typing in my tools, it's going to fill up my context window, right? So there's a problem. You can't load all the context in every single time that you go and send something to a language model. So now you have to understand structure. So with your team, one of the most critical skills that I tell everybody is go study agent.md or claude.md files. There's a website, you can go to it, agent.md. Claude have their own version of that. But if you're a developer today and you don't understand how to write proper Claude MD or Agent MD files and using AI tools, you're missing out. All right. So that is the number one reason why people don't understand how to use these tools, because they don't understand how to load context. How do these things fit together? The second part of that is just, on how do you put guardrails around these things? So first of all, when I said earlier, when we design autonomous agents, it's a crew and you have specific agents inside the crew. I never create one agent that does everything. I always break it up. So you have multiple agents doing very specific work. You can think about this as, if you have a background in service, microservices and things like that, where you have one or two functions, that's what you want to do. You want to have it very specifically focused on one problem, and that's it. You don't want a jack of all trades agent. This is where the problem comes in when you use these agents like Fable and all those, because they need to do everything. They don't do small little things extremely well. You're much better off focusing on giving a dumber model a very specific prompt. And that becomes your guardrails, because that model is not going to try and find a way to hack Hugging Face. I don't know if you guys saw that article a couple of days ago. That agent is not going to be smart enough to go and access a database it's not supposed to access. So my point is, when you create these models, you have to understand how to write the prompts, how to pick the right model so that you're not overusing the smartest model all the time. It's costly, but forget about that. It's going to try and guess things it doesn't know, whereas the other model, it might just fail. It might just give up. And that's what you want. You want it to be predictable. So those are the guardrails when you're developing agents. Now, outside of this, I'm talking a lot about generative AI and agents and stuff, but keep in mind, AI is much bigger than that, right? We talk about neural networks, we have regressions, we have decision trees and XGBoost and a bunch of other tools to our capabilities. That's another way to enforce guardrails. When we build agents, we typically don't have agents call language models for tools. We just don't, unless we have to write code dynamically and use a language model for that, or translate or create a document. We typically will call a RESTful endpoint, and behind the RESTful endpoint, there's a image generation model, or there's a neural network that does some kind of prediction, or a time series model, a REMA model, whatever, and it does exactly what it's supposed to do. It's predictable. We're working on a project now, and Alex and I are familiar with this one, where the client is building a voice assistant or voice agent for scheduling medical appointments. And we came into the project about 18 months into it being developed. And I started looking at why it's failing, because people would call and the next, they'll say their name. And then the next question from the agent is, what's your name? And the people get frustrated because they just said what their name was. And it's because the routing logic in that agent, instead of using a state machine, which is predictable, right? You have states and you have progression and you have transitions. That's predictable. Instead of using a state machine, as they should have, they use a language model to infer from the dialogue what the next action should be. Not the right tool. You don't use it for that. So that is I think one of the biggest challenges is these days is people use LLMs for everything because it's easy. They forget about software development. They forget about data science. And they forget about all of those practices that they learned they went to college with. And that's why when I say you still need a computer science degree, it's because those are the things, those principles. I still use object-oriented programming in my prompt design. That's how I do it. You can ask Alex. We actually have a plugin that we install Claude with all our agents and sub-agents as a base, with all the base agents. And then there's a variant. This is inheritance, right? In object-oriented programming. It inherits, it looks at the project, and it creates specialized agents for JavaScript or for C# or whatever you're doing. But it's very specifically focused. So every engineer in our teams can go install the plugin and then customize it to their tech stack. But the principles are software development principles. All right. I've been breaking the horse. The horse is dead on that one. So, Alex, what do you think? Like, just some of the transition, and that's the topic. If you scale your team and you're introducing AI, the systems, the processes that you've seen, especially around project management. I know are you certified in PIM?
I am PMI, yeah. But
Okay.
that's an interesting thing because project management is one of those things that is a very repeatable effort. It's the same, no insult intended toward any of the project managers who are here listening, but it's the same thing every day, same stuff, different day. This is where AI can help you. You can create better insight into what's really happening with the team instead of just going into a meeting, listening to what they're saying, and then writing down something and then coming up with a report for your boss. You can really engage with the developers, find out exactly what they're working on, what kind of problems they're having, and let the AI agent take care of all of the drudge. How many lines of code did you check in, and how much was your estimate, and which kind of estimate did you use? The T-shirt one or whatever. The point is that those kinds of skills are I'm not going to say they're going away, but they're becoming more commonplace from an AI perspective.
Yeah.
You need to start thinking more strategically on that. And that's how we scale our AI teams. We don't worry about the low level development effort. We're more concerned about how are developers thinking about solving the problem. What kind of ROI they're going to have when they solve the problem, and most importantly, do we even want to solve this problem? Is this something that we even want to get into? Something probably my boss doesn't want to hear me say, right? But
Yeah.
sometimes, a client comes to us and says, "Hey, we want you to build blah blah blah," and I'm looking at this, and I'm thinking, why? This is not going to help anybody. This is not going to do anything. Oh, and by the way, there's a company that did exactly the same thing 20 years ago. This is not really novel, right? So you have to think about how you're going to use AI to, excuse me, to better the team, not just
Yeah.
use it however way you want to do it.
So let's talk about our final topic is really some of the lessons learned, right? From some of the projects that we've worked on over the, so many years. The number one lesson, the number one thing that I would say is start with the workflow, not the model. And it's super important. It's the same concept when you talk about agents. The hardest question is where AI fits in that process, not which model to use. People always want to focus on, hey, did you see Fable came out? And if you go on YouTube, you will think you need to use that. You'll get that anxiety, that FOMO, and it's not focused on your process. It's not focused on your workflow. So one of the things that we do we for our clients is we build agents very often using open source models to keep costs down, for privacy. They want to run it on-prem. There's a lot of reasons to do it. They don't want to send their data into the cloud because they're financial or regulated, whatever the case might be. How do you do that if you don't have good processes? And that's why I say you always want to start with the workflow. And that's why our process of creating agents starts with archetype, persona, journey, tasks, behaviors, decision points. That's the process. And if you don't have a process, you don't have a workflow defined, don't start coding. That's number one. Number two, I would say, is you have to define success metrics before you build. Very often, this is where people go wrong with AI. If you go read the Gartner reports where they say 90% or 80% of all AI projects fail, it's because the expectations were wrong. People have high expectations because they read something on LinkedIn or X or whatever, or their bosses tell them, like somebody was asking earlier, the CTO has to push back on the CEO that heard something. Hey, this is what we need to do. So what are those measures? And I'll go back to our process, right? Our 8 to 10 weeks, that first part of any AI project that we do at Svetla is always to determine what is the right ROI. I can't emphasize that more. And the ROI, I want to give you guys an example because this is outside of data science and analytics. People don't really realize this. If I had to build a monitor at my front door that 100% of the time blocks intruders. Do you think that's possible? I want people just, just if you want to drop in we don't have chat. So in the QA, if you think it's possible, just say yes. If you don't think it's possible, just say no. I want to see. No. I'm going to prove you guys. I'm going to prove to you in a minute how it is possible. All right. Here's how it works. So we have recall, we have precision, and we have accuracy. Those are the main three ways of monitoring a model, right? To see how well it performs. There's others as well.
Speed.
Speed, there's another one. But if we look at those, right, every one of them, it's almost like a triangle that you have to pull. You're going to increase recall versus precision. And, the precision goes down if recall goes up. Gary got it. If I block everybody 100% of the time that enters the door, if I detect any person and I just say, you can't enter, I'm at 100% recall. So it's very easy to build a 100% recall model, and I can use that as a measure, but it's the wrong measure. Okay, so now what is the opposite of that? What if I catch every single person that enters, but every now and then I also catch when the cat walks by and I alert Alex and say, hey, there's an intruder, but it's actually just a cat. Is that acceptable? That's a lower recall, but it's a higher precision. So when you think about recall, accuracy, precision, all of those things, you have to adjust it, and it's based on the case. How about cancer treatment? There I cannot be wrong, right? I also can't say 100% of the time, just give everybody the medicine. So how do I measure that? How do I get to a 99.99999% precision or accuracy or recall? So my point is, people don't really go into AI projects thinking of how to measure success and how to, again, I said this in the beginning, how to link what you know technically to business needs. All right. That's the superpower today, is being able to, what I just did, translate the technical feasibility into a business need or a business explanation. And that's one of the things we deal with every day. Every day, Alex and I need to explain to people, what does this mean? How do you interpret this? And that's fine. That's what we do. We're supposed to be the experts, right? But that is one of the skills that I think is important to learn. Next one is observability, right? That feedback loop. So Alex, I want to hear in a minute, I want to hear how you think about, like, on the services and the performance side. So I'm going to focus just on the model side. On the model side, a model that breaks does not break like an API, 500, 400, 200 errors or whatever, right? It doesn't break like that. A model breaks when it makes a fake prediction. When you're asking it a question and it gives you the wrong answer very confidently. All right? So you need to be able to have observability that's focused on model performance outside of model performance. And you understand what I mean with that. So on the performance side, on the technical engineering side, Alex, like, what's some of the things that that you've dealt with, that you've learned from that
I think
relevant?
Yeah, I think one of the most important things that people forget is that AI is going to very confidently give you the wrong answer, which means that it's going to fail at something. And people completely miss that boat, or they don't think about it. So the question is, what are you going to do when the response that you're going to get, or the result that you're going to get, is not a good result? For example, let's say that you're scanning documents and you need to be very precise because you're an accountant. You want to scan people's tax returns or their W-2s or whatever. How bad is it going to be if the information that you're pulling from that vision AI is not going to be very precise? To your point, you have precision, you have accuracy, and in this kind of case, you may need to have performance of speed, because you can't just spend 10 hours looking at one piece of paper. You have to look at one piece of paper for maybe 5 seconds, move on to the next piece of paper, because you're hosting lots of other customers on the same environment. So you need to understand that AI will look at this paper and say, oh, very confidently, hey, yeah, this is a W-2 and it's got this number and it's got that number, but you need to determine how accurate is it? And if it's not, what do you do? What do you tell it to do in order to improve that? So in some cases, you may need to escalate. In some cases, you don't. But my point is that you need to understand and take into account the fact that sometimes these things are not going to go your way. They will fail, and you need to, as a good engineer, if something doesn't come back, what do you do? You know, for example, when we worked at Bankrate together, we connected with other lenders to get rates and whatever. Sometimes those lenders, their machines were down. So what do? We
Yeah.
can't just assume that the API will always work. So you have to put in code in there to ensure that if something isn't working, you can keep going. Same thing with AI. A lot of people forget about that.
So when I went to college, I studied data science. I did my master's. We were told there's a guy, a statistician called Johann Beukes, and he said all models are wrong, but some are useful.
Yeah. It's just like, you know, your your watch may not be working, but it tells you the right time at least twice a day, right?
Right. So the thing is, you need to kind of understand that these models aren't perfect. And I think that would be like one of the last lessons that I want to share, and then we can go to questions. But assume that the model is wrong at some rate. Assume that. So you need to have in the software architecture, you have to design with failure modes. There needs to be fallbacks. There needs to be confidence thresholds. This is one thing that I don't understand why ChatGPT and all these tools don't have it built in, where when they give you an answer, there should just be a confidence score. If we were trained from the beginning, but here's the problem. Their confidence were pretty low in the beginning, so they didn't want to share that. So now we're hooked. Now they don't have to share it, right? But if we design it for our clients, we always include confidence scores, and you have to, right? You want to know how confident are you giving me this answer? If it's below this threshold, ignore. Give it to a human. And that's the next thing. When you build these systems, you always want to have a path that escalates to a human. That human in the loop, it's like the Tesla analogy, right? Tesla is leading cutting edge when it comes to autonomous driving, but they still have a steering wheel. Even though they're removing it from the taxis I saw, we'll see how that goes. But you still need the human in the loop today. And especially in business, I would say very critical in a car as well. But if you just focus on what we're building, we always have a human in the loop, especially when a project is new. It's unpredictable. We're just getting it into production to see how it behaves with production data. Those are all things that you have to take into account. So if I very quickly summarize lessons learned, right? Number one, you want to start with a workflow, not focus on the model. Goes for autonomous agents, goes for coding agents, all of them. You want to define the success metrics. You want to understand, how does this actually bring ROI? How does that connect to the business value? One thing that I forgot to mention along with that is you want to ship narrow. We talked about it a little bit, but you don't want to build something that is a general agent. You want to focus on specific areas. And that's how you ensure that your agents are going to perform really well. You want to design for failure modes. And those are some of the main, I want to say the last 2 years, some of the main takeaways that I have from every single project that we focus on. All right, with that, I want to go to questions. I want to make sure, we don't miss out on the questions. We have about 6 minutes.
I've been actually trying to do my best in answering a lot of the questions that are scrolling by. So while you were talking, I was like typing to respond to some of these questions.
All right. I think we had a few. So automating updates to your context structure is everything. Yes. Okay. Without context engineering, Hugging Face. Okay. What are the outcomes you are seeking, or rather, what problem are you solving, and how will you know? Okay, so what Russell is saying there is, when we talk to any stakeholder, it could be a CTO and others. We very often, those are the people we work with, right? We ask them the question of, what is it that the business wants to solve? And if the CTO can answer that, let's go talk to the person that's going to use the technology. Let's find out, what do they expect? That upfront expectations helps us to plan for the right solution, but also the right measurement of the solution, right? We were talking this morning in one of our meetings, we were talking about, if I was to create a $75,000 solution, right? But today it's being done by a person, and we're paying that person part-time $200 a week. Why would I spend $75,000? Even though I can solve the problem 100%, get rid of that person, the ROI is not there. So you always have to think upfront, what is the actual way we're going to measure success on this? And it doesn't make sense. Like you mentioned that earlier, Alex. Let's see, there is data drift. Yes. So let's touch on that quickly. With all AI, if it uses data, and most AI solutions have a need for a lot of data, data will change over time. We saw that with COVID. That was an extreme event, but we also see it. If you've ever tried as an amateur to predict the stock market, you know exactly what I'm talking about. We have seasonality. We also have what they call cycles. So those two things aren't the same. They have the same effects, but the different time scales. Think of weather, the weather over the next 5 days. That is something that is kind of predictable because we're in that cycle, but we wouldn't call it seasonality, the weather for the next few days. It's more cyclical. You know that, evenings and days and mornings, and especially in Florida, it's going to rain. It rained when we started this webinar, and now it's sunny outside. I expect that in Florida, right? That's the cycle in the summer. However, that's the seasonality during the day. The cycles, however, are a little different. So think of El Nino. That's a cycle. We know on average when it's going to happen, but we can't really pinpoint it. Whereas I know in the summer it's going to be hurricanes and rain in Florida. It's very predictable. I don't really know in 100 or 200 years from now if that's still going to be the same. So my point is, when we look at data changes over time. And that's one of the reasons we always implement monitoring, visibility, logging, all of the things that you need in order to monitor and see when the data starts drifting, you need to know about it. There's also model drift. There's also concept drift. And I can get into those, but I won't now. But definitely there's a lot of things, or a lot of reasons to monitor the performance of these models outside of, is it up or down? All right. How can confidence be measured if the data is evolving, updated every day? So Minnie, that's a good question. When you do evals, you don't look for a model to answer a specific question. You look for a model to answer a specific set of questions. So evals are testing ability. Evals aren't for testing facts. You can create evals for factual checking as well. That's a different test. But when we test to see if a model is performing where it should be, does it answer questions about if I have a model that predicts, what I'm going to eat the next 24 hours? Is it pretty good at predicting what I'm going to eat? Not that I'm eating potatoes and steak and all that. That's the facts. So it's just how you design your evals, how it's going to know, even if the data changes, does it understand the concepts? And that's the beauty of the language models that we have today. They're really good at concepts, not just words. If you asked me 5-6 years ago, before around 2020, any language related stuff, we would have used NLP and NLU. Those are the two technologies that predates language models or transformer architectures. At that point, it was all about keywords and entities and things like that. Now we're more in concepts. All right. Okay, in general, LLMs are terrible at accurately providing their own confidence. That's right. You always want to use a judge. So we create judges, different, it could be a different model, family of models, but we always have a judge that judges a model. So it's very antagonistic. And if you're familiar with neural networks, there's architectures in neural networks that, and now it slipped my mind. Oh my goodness, adversarial networks, where one network is trying to outperform another network, and you have these two networks fighting it out to come up with an answer. And that's basically the same concept when we are evaluating language models. I see a significant interest in investigating AI models driven by a fear of missing out. Absolutely. Once some of the people in our organization find out what AI models can do, they pivot to fear, uncertainty, doubt. Yes. So the challenge, Gary, is that this is where the change management comes in. like I told you, we train engineers. We have 12 sessions where we train engineers how to use tools, and we include management. We also include the product managers that comes up with requirements. The very first two sessions is talking about how your role is going to change and also how your process is going to change, your SDLC process. The reason we do that is we address that fear up front. Where are you going to fit in? We're going to show you how to use these tools, but let's just talk about it. Where do you fit in this new environment of AI tools and stuff like that? I think people jump just like the model, right? They jump to the model, they jump to the solution before they think about what is the workflow, what is the process, what is the change management that goes along with this. And the higher you move up in management, the more of a concern that should be. All right, let's see. I think two more questions. I see a significant interest. Okay, that's what we just did. All right, I think we got through all of them.
Yep, I think we did. So guys, just to recap, we talked about why AI projects are sometimes slowing down after they pilot. We talked about scale. We talked about building teams and how AI can help. And Johann and I talked quite a bit about some of the stuff that we've learned from real world AI implementations that we've done for our clients, as well as for ourselves. So if you guys have any questions, feel free to send us messages on LinkedIn. If you guys need any assistance, we're here to help. So thank you for joining, and hope to see you again, because we're going to be doing this again in a few weeks. So have a wonderful day and have a wonderful weekend.
Thanks, everybody.